Hey, hi everyone. So today we will be solving this problem, binary subarrays with sum. So in this problem we are given an array of zeros and ones, and we are also given a goal, and we have to find how many subarrays exist such that the sum of those subarray is equals to this goal. And one important thing is that we have to only we have to only include non-empty subarrays, right? So if we take this example, so 1 0 1 0 1 and the goal is 2. So we can see that this is one of the subarrays which has sum as 2. This is another subarray which has sum of 2. So and in a similar way, this is another subarray which has a value of 2, and this is another subarray which has value of 2. So we can see that there are 4 subarrays such that their sum is 4, right? So now let's try and understand this problem, and let's go to our screen and try to come up with solution for this. So yeah, so if we take a look at this example, so in this subarray we are given 0 1 0 1 and 0 1, and we are given the value of 2, and now we will be counting how many subarrays exist such that their sum is 2. So this is one subarray, so we'll count here. This is one subarray which has sum of 2. This is another subarray which has sum of 2, and this is one subarray which has sum of 2, and this is another subarray which has sum of 2. Do there exist more subarrays? Yes. Okay, we have included this, right? We have included this. Okay, so we have not included this. So this is another subarray which has value of 2, and what else? 1 1 2 3 4 5 and 6. I don't know the actual count and I don't know the actual answer, but I hope you guys understood about the problem. So now let's try to come up with solution for this. So number one approach for this problem should always be, so like for this kind of problems we should think about sliding window approach. So if you remember in the earlier problems, we have firstly gone to sliding window as our solution, and then we kind of saw why that solution won't be working. But in this situation we can see very clearly that so we'll be maintaining a sum variable, we'll be maintaining 2 pointers left and right, and while your sum is less than goal, we are going to expand this window, and we are going to expand the window towards the right side, and if at any given point of time our sum becomes equals to goal, we should be we should be increasing the count. While on the other hand, if at any point our sum becomes greater than goal, then we have to shrink our window, and then we have to shrink our window by excluding from the left. So since this is a valid way, so if we are actually increasing if we are increasing the size of our window and moving, so let's suppose if it is your right pointer, you are moving in this direction, and this is your left pointer, and then you are moving in this direction. So if we are expanding, we are moving in this direction, and in this manner, since our array only has zeros and ones, it is guaranteed that sum will also increase. Similarly, on the other hand, if our sum becomes greater than goal at any given point of time, we will be shrinking our window by moving the left pointer, and since our array always has zeros and ones, it is almost guaranteed, or not almost, it is guaranteed that our sum will shrink if we increase L. So yeah, that should be one of the solutions, and sliding window will actually work in that scenario. But now let's try to talk about another technique to solve this problem, and we will actually be looking like in a detailed manner in another video for this question. I'll be uploading another video for this question, and there we will be discussing how to solve this question using sliding window. Now let's try and solve this question using another technique. So okay, so we have this array and the goal is 2. So if we try to build this problem using the same idea that we used for another problems, so we can see that if we want to find a subarray with sum k, and how did we used to solve these problems? We used to solve these problems by using this basic mathematics idea that from a given index, if sum is x plus k, and if there exists a subarray which has sum k, then basic mathematics say that the sum of the remaining subarray should be k. So again we will be solving this problem using this technique. And how are we actually going to calculate the subarray sum from index 0 till I, and then from index 0 till j? We are going to maintain a prefix sum, and then we will be solving this problem. So yeah, let's get right into this. So we will have a prefix sum. Initially our prefix sum is 0, and since we want the count of elements, and I think we have discussed this earlier also, that there can be multiple instances where your prefix sum can be same. So for example, if let's say if I have this array 0 1 0 0 0, so prefix sum at this position is 0, and prefix sum at this position is also 0. Prefix sum here is 1, here is 1, here is 1, here is also 1, and then prefix sum here is 2. So if we have to count how many subarrays exist between these two, so let's say the prefix sum from here to here is 2, and prefix sum from here to here is 1, and if I have to count how many subarrays are present in this scenario which have sum of 1, so we can see that in this space there exist how many subarrays? 1, 2, 3 and 4, right? And that is equal to the frequency of this. So we will actually be using the frequency of these prefix sums in order to make sure that we don't lose upon any solutions, right? So we will also be requiring frequency. So the frequency of 0 here initially is 1. The frequency here is, now we will actually be traversing this array. So the prefix sum at this position, and let's try and mark the indexes 0 1 2 3 4 and 5. So prefix sum at this position is 0, and we are actually interested in checking if 0 minus goal, which is 2, exists in our array or not. And since we are also interested in finding this kind of queries to find if a prefix sum exists or not, we have two options. We have set or map, and since we also want to keep track of frequency, we will be using we will actually be using map for this implementation. So yeah, so now we will be at this position, we can see that the sum is 0, so we will actually check whether 0 minus 2 exists in our map or not. Since 2 does not exist, but what would have existed, what would have happened if minus 2 had existed? If minus 2 had existed, then that would have meant that there should be a subarray with sum of 2, so that this balances out, this natural maths balances out, right? So but since minus 2 does not exist, then we don't add anything to our count variable. So initially our count will be 0, and as we find more subarrays, we will actually be increasing this count. So since there is no subarray right now, we'll just update the frequency of 0 to 2. Now at this position our subarray sum becomes 1, so we will check whether 1 minus 2, which is equals to minus 1, exists in our prefix sum or not. So since it does not exist, but what would have happened if minus 1 had existed? So from here to here our from here to here our subarray sum is 1. If there had existed a subarray with sum of minus 1, then that would have meant that there should also exist a subarray with sum of 2, so that the natural mathematics balances out to eventually make this subarray sum equals to 1, right? So yeah, since it does not exist, we simply update the frequency of 1 from 0 to 1. Now at this position again our sum is 1 and the frequency is 2. We have seen that minus 1 does not exist in our array, so we simply move on. Now at this position our prefix sum becomes 2. So we'll check whether 2 minus 2, which is 0, exists or not, and we can see that 0 in fact exists in our array. So if we take a look at this position from here to from starting our prefix sum is 0, okay, so from here to here our prefix sum is 2, at starting our prefix sum is 0, then that means that from here to here our prefix sum should be 2. Is it 2? 0 1 0 1. So yeah, prefix sum is 2, and also from here to here our prefix sum is also 0, so that should mean that prefix sum of this the sum of this subarray should also be 2. Is it 2? 1 plus 0 plus 1. So yeah, it's also 2. Then what does it mean? That we will be updating our count to the frequency of 0, which is 2, right? So we will be adding 2 here, and we will also update the prefix sum, the frequency of this prefix sum, which is 1. Now the prefix sum at this position is again 2, and again we have seen that 2 minus 2, 0 exists, right? So we'll again update the frequency, we'll update the count to plus 2. Why 2? Because the frequency of 0 is 2, right? And another thing we'll do is we'll also update the frequency of this prefix sum from 1 to 2. Now at this position we find that our prefix sum is 3, and what we are going to check is whether 3 minus 2 exists in our map or not. So 3 minus 2, in fact it does exist, right? So what is the scenario here? The scenario here is that from here till here our prefix sum is 3, and from here to here our prefix sum is 3. So that means that the prefix sum, the subarray sum, okay, so I think I said something wrong. Okay, so let's try and again let's try and do this again. So from here to here our subarray sum is 3, and we see that from here to this position our subarray sum is 1. That should mean that the prefix the subarray sum of this subarray should be 2. So yeah, this is 2, and also we see that 1 appears twice in this subarray, in the prefix array, in the prefix sum map, right? So from here to here also our no, not here, from, so how many times did 1 occur? Okay, so it comes as 2 here, right? So from here to here our subarray sum is also 1. Then that should mean that the sum of this subarray should also be 2. So is it 2? Yes. So we'll again update our count variable to plus 2. Why 2? Because the frequency of 3 minus 2 is 1, and the frequency of 1 is 2. So we'll update our count variable to the frequency of 2, and once we have iterated this whole array, also we'll update the frequency of 3 to 1, and once we are done iterating, we have stored our answer in this count variable, and we will simply be returning this count variable in the answer. So now let's try and code this solution. So we'll be maintaining a sum variable, and we will also be maintaining a map of sum versus frequency, and we also want a count variable to count how many subarrays exist such that their sum is equals to goal. So now we'll iterate this array, and we'll include this in our running sum, this index at our running sum. And what we are going to do is we are going to check whether sum minus goal exists in our sub array or not. If it does exist, we are going to increase the count variable to the frequency of this sum minus goal. And if it does not exist, if it does not exist, we are not going to update this thing, but we are also going to increase the frequency of our sum that we have gotten so far, and finally we will return the count variable. So, and one more thing that I forgot here, so at the start of our iteration, we saw that we had used we have inserted this thing that at the starting the subarray is the subarray sum is 0 and it has occurred exactly once. So now if we try to run this solution, let's try and run this code to see if we are getting the right answer or not. I'll return the I'll reset the test cases. So the example test cases are running. Now let me try and submit this solution. Okay, so all the test cases are passing. So let's analyze the time complexity of this solution. So we are simply running a for loop. So the time complexity is going to be O of n, and for the space complexity part, we are using an unordered map, and in the worst scenario we can have all the unique prefix sums, and for each index, so the space complexity will also be O of n, where n is the size of the array. So yeah, that's all for this video. I'll soon be uploading another video to solve this question using sliding window technique. So yeah, thank you.